Okay, in this video, I'm going to pick up where I left off and try to work through number 16 with you. This is the last question in the practice test that came from our identities section of the class. And from number 17 and beyond, we'll be dealing with trigonometric equations. With that being said, we're told that tangent of theta is equal to 2/3. Now, let me just share something with you and remind you of this. We're going to consider this theta, this unknown angle measure, both in terms of a unit circle as well as a right triangle. As far as the unit circle goes, let's see here. This is a positive number, positive 2/3. And if you remember the phrase, all students take calculus, that reminds us that the tangent function is positive in the first and the third quadrant. So in order for tangent of some unknown angle measure to be a positive 2/3, well, that tells me that that angle has to exist somewhere in the first or the third quadrant. Now, I don't know where that lives because I don't know the angle measure, but I do know that tangent of the angle measure is a positive 2/3. Therefore, the angle has to be somewhere in quadrant 1 or quadrant 3. Now, Math Excel does go right on to say that the angle measure must be between pi and 3 pi over 2. Well, those are angle measures in the third quadrant. So now we're dealing with an angle measure that sits over here, somewhere in the third quadrant. Now, it would be also helpful to note what the right triangle might look like in order to help us establish what sine and cosine based on that angle measure is. And we can do this here. Remember, tangent of some angle is equal to the opposite side length divided by the adjacent side length. So I'm drawing the triangle in this orientation because I'm imagining my unit circle sitting here somewhere. And this particular triangle is larger than the unit circle because the opposite side length is 2 and the adjacent side length is 3. And I'm talking about opposite and adjacent relative to this angle. Moreover, since we're dealing in the third quadrant, and if we had this Cartesian coordinate system here, this horizontal distance would be -3, and this horizontal distance would be -2. Now, in reality, we're not talking about a distance of -3 or a distance of -2, but the value -3, -2 helps us define the position of this point relative to the origin, and it'll help us correctly identify the results for sine and cosine. Now, since a squared plus b squared equals c squared, the Pythagorean equation holds true for this, I can find the length of the hypotenuse pretty easily. So I'll just do this real quickly here. -2 squared plus -3 squared is equal to c squared. Well, that's 4 plus 9, so that's 13. C squared is equal to 13, so therefore c is the square root of 13. That's helpful. Let me write it in red so that it's the same as the others. Square root of 13. This is helpful because now we can, with some certainty, identify the resulting trig equations or trig expressions. Tangent, we said, was equal to 2. Wait, was it 2/3? Yep, 2/3. And notice too that -2 divided by -3 would also be positive 2/3, so that's okay. Sine of theta, which is our opposite side length divided by the hypotenuse, will be -2 over radical 13. If we hadn't considered our signs of the numbers here, we would get an incorrect sine calculation and cosine calculation for that matter, because cosine is the adjacent side length, -3 over radical 13. Okay, so that's helpful because as we saw in problem number 15, the definitions of our double and half angle identities utilize those expressions. The double angle identity for sine looks like this: 2 sine theta cosine theta. And when we make our substitutions, we have this expression, which when multiplied will simplify to 12 over 13. In part B, we again think of an appropriate trig identity. Now remember, with the double angle identity for cosine, there are three different forms, and depending on your situation, you might find one that's more helpful. I used this form in the last video, so I'm going to use something different here just because I can. I'll just use this first definition. So cosine squared minus sine squared is our double angle identity for cosine. So when substituted, we see this expression, and simplified, -3 squared and square root of 13 squared becomes 9/13 minus 4/13, which to me looks like 5/13. Now for the half angle identity for sine, let's remind ourselves this half angle identity for sine takes on a value either positive or negative as appropriate. So it's worth noting here that if theta, the original angle, exists between pi and 3 pi over 2, then half of theta, if I were to divide it by 2, it would mean that my domain also gets divided by 2, has to exist between half pi and 3/4 pi, because 3 pi over 2 divided by 2 is 3 pi over 4. In a unit circle, pi over 2, of course, is this vertical angle, and 3 pi over 4 is this position here. And so the half angle, theta divided by 2, produces an angle somewhere in between these two gray marks. And so this angle produces a positive sine value. Anything in this position has a y value that's positive. So I know that for sine of half of theta, I want to use the positive format of the half angle identity. So positive square root of the quantity of 1 minus cosine divided by 2. And there are several steps needed to simplify this expression, but I do believe Math Excel will accept this as long as your work leading up to this is correct. For cosine of theta over 2, we're again talking about an angle measure that's in this gray area, and in this gray area we have an x value that's negative, so the cosine result of theta divided by 2 is going to be the negative format to the half angle identity. And I would be satisfied with this as a result. Take your time simplifying in order to satisfy Math Excel if they so require. For tangent of 2 theta, the double angle identity looks something like this. And when substitutions are made, the math isn't nearly as challenging as fractions with radicals. So I'll go ahead and take a moment to simplify this. But here again, I'd be willing to try this in Math Excel as an answer. I really don't want to go through the trouble of finding a common denominator in the denominator to combine those two to a single fraction, and then with that fraction, divide the numerator fraction by the denominator's fraction. Those are just additional algebraic steps that may not be necessary when entering grades electronically online. For the half angle identity for tangent, we've got this equation. And I would probably leave this expression as it is. Don't be tempted, or don't follow through with the temptation, let's say, to cancel this with this, or this one with this one. While you might be tempted to do so because those elements exist in both the numerator and the denominator, we can't cancel them. They're not common factors because these elements are separated by an addition and subtraction sign. They'd only be common factors, and they'd only be eligible for canceling if the sign between this number and this number was multiplication, or between this number and this number was also multiplication. We don't have that, so we can't simplify. So to that end, I would again try entering this into Math Excel before going through the trouble of simplifying it by the multiple algebra steps that are necessary. Now, if you would like to try that, here are the solutions to those 6 parts. These would be the answers that Math Excel would expect you to report. But again, they're not the only answers that Math Excel will accept. So again, this became a lengthy video. Question 15 and 16 are quite involved due to the multiple parts. I'll stop the video here and pick up with the next one when we start with the trigonometric equations.